Hello, everyone, and welcome to today's webinar. My name is Phil Newman. I'm the editor-in-chief of Longevity.Technology, and today's Investing in the Age of Longevity is a webinar hosted by Master Investor. Now, this forms part of the 2024 Longevity Week, which has been happening all week in various locations around the UK. And today we're splitting our program into two sessions. We've got what I kind of broadly call Longevity Next, which is the future of longevity investment, kind of higher risk and higher reward. And then we're going to be moving into Longevity Now, which is those companies that are forming part of the longevity economy with identifiable revenues and likewise possibly a lower risk profile. So we have a real stellar cast of speakers today, and I would encourage you, if you feel brave enough, to use the Q&A channel to pose questions. I'll do my very best to keep a track of your questions and then bring those into play if there's time at the end of each session. And delighted to say we've also got a panel session at the end of today. So if we don't get your questions in early, then we'll try and address those later in the session. So I don't know if many of you know Longevity.Technology, but we are an organization that's been working in the longevity space for quite a while. And I'm going to take this opportunity to, first of all, share with you our overview of the longevity market, both from an investment perspective, but also share with you our new classification that we've been working on for the work that we're doing in analysing the industry. So let me just take you through some key slides to get things started. There's my QR code. So if any of you would like to contact me or would like a copy of my slides, I'm sure the Master Investor team will make that possible as well. But likewise, there are my details if you'd like to reach out to me. Please feel free to do so. So first of a little bit of a homage back to the team at Juvenescence. We've got Greg Bailey joining us today from Juvenescence. In fact, it was Juvenescence's Series A round of $50 million back in 2018 that was my trigger of getting into this sector. I first heard of the term anti-aging back at that point, and I was actually doing a 500-kilometer, 24-hour bike ride in Norway at the time. That's me asleep, literally asleep in a lay-by in Norway. That was the beginning of my longevity journey, and I'm sure some of you are perhaps dialing in for the first time to learn more about this very exciting sector. So the way that we look at the industry is across business and science news. So we have Longevity.Technology. We also have an investment portal and likewise a lot of work going on in consumer education, and talk to you later about what we're doing with our investment activities as well. So looking at 2024, where are we? Well, I'm sure most of you are aware through the media that people are talking about longevity very significantly now in the space. We've got influencers coming into the space, but likewise, we've got big corporates coming in too. And I'll talk later about what's happening in the field of the big pharmaceutical companies as well, because they're part of this industry as we have it standing now, but likewise very much part of its future. So some big numbers on my screen here. So what is the longevity industry and how do you count it? And of course, we all like big numbers and charts that go in the right direction. But many people look at the industry across very different scopes. So whether it's longevity supplements or retirement homes or even luxury cruises, the key thing is how big is this sector and how do you actually analyze it? So that's what we do. We analyze the industry across 25 different domains. You can see them all here. These toggle between the longevity now and the longevity next aspects of the industry, as I mentioned earlier. And we publish annual reports and quarterly reports about the space. And I'm going to take you through some of the details that came out of the first half of 2024 report that we've just published. So you can see here that 2021 was really a breakout year for longevity investments, just over $10 billion. And interestingly, you can see that there's a toggle between 2021 activity and the drop off in 2023 in terms of investment activity and what that looked like in terms of company formation. So even though there wasn't necessarily the capital flows that we would have expected, there was still a lot of activity in the formulation of companies in the space. Very pleased to say that things are very much back on track for 2024. You can see here that this is the first half 2024, which when you combine it with the second quarter of 2024, those two combined actually made up more investment than the whole of last year. So things are very much moving in the right direction for the industry from a investment perspective. And you can see from those 25 domains that I just shared with you earlier that in fact it's longevity discovery platforms in Q1 that were the breakout category for attracting investment, $1.4 billion. And I would say, in many respects, the longevity discovery platforms, which are those companies that are, excuse me, using AI to discover unique molecules and using AI in silico, in computer, to be able to identify whether they have potential efficacy in humans in the future, they have been a very big category for many years in the space. And it's very interesting to me that when you look at the second quarter of 2024, that in fact it was then actually a category of neuropharma that overtook that. And that's kind of a trend that we're seeing in the space now, because these AI discovery platforms are putting out a lot of assets, but you've got to do something with those assets. As I'll talk with some of our presentations today, the key thing is that it's how you take those assets through the clinic. And when you get those into the clinic, which means that they're going to be put in humans, are they going to be proving safety, both safe and efficacious? So the trend is moving around to swinging around to assets now, which I'll be talking about with Greg Bailey, I'm sure later. But when you look at the scope of the industry, it's a very exciting industry. It's confusing for many, whether you've got a single asset like a neuropharma asset like NeuroBio in the top corner there, or even a group like Human Longevity, who are a clinical group using full body MRI and other diagnostics to help people at a clinical level. There's a lot going on in the space, and it is quite confusing. And I have to say, I've got a role in trying to help clarify it, but likewise, my own journey was part of that spaghetti, which is the fact that obviously this is an interesting space, but it is highly confusing to people. So we have recategorized longevity across the 10 levels that you can see here. And I'm going to take a spin through each of these levels so you can identify how we've categorized them, but likewise where we see the investment opportunities for them. So all good longevity theory starts with the basics. So this is managing our diet, sleep, exercise, and so forth. And there are a lot of organizations in this space, as you can imagine. And this is everybody from the big players like Apple and Google through to other wearables like Aura and others like Ultrahuman that are helping us understand our behavior, whether it's our sleep or our exercise. The key thing is that actually this is moving into a trend now where there are opportunities for companies backing into that infrastructure, not to take on Apple and Google, which is going to be very hard to do. But as you can see here, working with helping people get that information into the systems in a much more efficient way. Some of those biomarkers that they've got, perhaps where they're doing a blood draw, for example, how you get that into your Apple app. And likewise, how organizations can use AI now to really hyper-personalize the way that this information is interpreted from a personal level. And we're seeing a big move now from longevity into the gym sector. So a lot of longevity gyms are getting into, a lot of gyms are getting into the longevity agenda now as well. Consumer diagnostics is a big part of this as well. This is helping people understand what's the difference between their biological and their chronological age. There's a lot of confusion in the space. It's still an emerging space, but really these companies that are moving into the point where you've got a valid biomarker test for age that works both in a consumer market, but also in a research and development market, that is going to be where a lot of companies are moving into the space. And those companies are attracting capital at the moment. Very exciting for us. We as a company today are going to be announcing our first move into the supplement space. And in terms of what we are doing and what others are doing in the industry is really using strong evidence behind the products that they are promoting, because some of these molecules are very strong and they have an effect on people as a food ingredient, which is what a supplement is. But likewise, a lot of these companies are now building clinical evidence so that they can actually be transferred into the clinical community as well as into medical care. So there's quite a lot of activity going on in the supplement space. Those companies that are using AI to identify unique molecules, they're big players in the space, but still very much emerging. And then, as I mentioned earlier, with supplements and clinics, the longevity clinical space is completely blowing up at the moment. Very exciting, lots of very interesting organizations being formed, big capital going into the space, growing interest from consumers. And of course, these clinicians are a key bridge for us to understand how we get into the longevity regimes that we need to protect our health span. Clinical experts are really important to that. And what we're seeing now is that there is an opportunity for all of the picks and shovels for that space to be actually developed. Operational IT systems, taking all this complex personalized data, putting it into care plans. I mentioned earlier the longevity gym and the luxury resorts are getting into this. And then likewise, there's a whole supply chain working now with these clinics that are either going to be supplement manufacturers or they're going to be equipment manufacturers. And they are emerging all around the world now with things like red light therapy and so on. So level 5 is when we get into the traditional management of aging diseases. And this is as close as we get to the current, what we would call a sick care paradigm. Obviously, we call healthcare the healthcare industry, but in many respects, what it's doing other than preventative activities is really helping people with an aging disease. So, of course, a lot of companies in the space, and we'll talk about those today, are using aging pathways to use a target disease as a way of actually getting the right clinical and as well as commercial pathway into the marketplace. But as you'll see later, we're seeing some companies now that are moving into these later stages of clinical development into phase 2B, where these can either be IPO targets or they could be acquisition targets for big pharma. Then, of course, you've got aging prevention, which, of course, is these diseases that we all get when we get over our 60s. If we can prevent those from happening, then all good. And, of course, those companies that are working on aging diseases are then working on preventative therapies. So this is very much the 4Ps, the preventative part of the 4Ps. Again, highly acquisitive targets in the future. And then we're going to be speaking to our first presenter today, Daniel Ives, and his organization are doing what we're talking about here, which is looking at targeted age reversal, which is working at a very complex cellular level to use partial cellular reprogramming to rewind a cell back to a earlier state while keeping its cellular identity, which means that you can actually then go from the potential of an individual organ and fast forward to the future to maybe being able to look at every cell in the body and do systemic age reversal, which is what we can see here. This is something that's attracting, again, a lot of attention, very scientifically complex. And we're seeing that really this is the specialist VC and ultra high net worth category of where money is going at the moment. As you can see here, xenotherapeutic and mitochondrial function dysfunction technologies are part of this. And we've got Kevin Slawin joining us today to talk about xenotherapeutics, which is the concept of being able to rejuvenate all of the cells in the body. So quick calibration point. The reality is that this is science that is still very early in many respects. So the key thing that we should all remember is people talk about is the longevity sector going to get its ChatGPT moment? Well, yes, but it's going to happen slowly. So the AI sector is away, as we all know. These guys have got regulators trying to catch up with them. The same with things like social media. The reality is that the longevity sector, whether it's in a clinical environment or even in a supplement environment, but very actively in a biotech environment, has got the regulatory pathways that it needs to go through. So there's always going to be a pace to this industry and the necessary quality checks that are required for any industry in this space when you're putting complex therapeutics into humans. So it's going to happen at a slow point. This is how Swiss Re, the big reinsurer, considers that regenerative medicine and likewise rejuvenation looks in terms of the timescales. Now, speak to anybody in the industry, and as we're going to do today, they're going to take a very different perspective of that. But the reality is, of course, is that this is complex science. So when we talk about longevity now and we talk about longevity next, the key thing is what does it look like between those two paradigms? So if we can't move that quickly, there are organizations that are working on organ preservation and organism preservation. So this is the concept of keeping the engine running while you're waiting for these therapeutics to come through. So we're seeing things like organ replacement, which of course has got some supply issues. So actually generating organs in, for example, in xenotransplantation, where you've got tailored organs being grown in donor animals. Likewise, 3D bioprinting, and there's even concepts out there about things like head transplants. So there's some concepts out there that are on the peripheral end that are quite interesting from a technical as well as a commercial perspective. And I'm delighted to say that we've got Emil joining us today to talk about something which is really a trend that's come back in from the 70s and 80s, which is cryopreservation or corporal preservation. So the concept here, of course, is can you, if things are too late, can you get to the point where you are resuscitating the body to the point where it can be re-engaged when these therapies come through, whether that's going to be 5, 10, 30 years or whatever it may be. So we're seeing now a lot of trend between the updates on how cryotherapy works, and I'll let Emil talk about that, but also the concepts of even digital immortality with the advent of brain-computer interfaces, quantum computing and AI, there is the inexorable move of us much closer to machines. So this concept of the singularity might be something that could to come into play there. So that's a quick spin through. As I say, if you want my slides, I'll make sure that you get those as part of the pack afterwards, or if you took my QR, please reach out to me for that. But I'm delighted to say that we're going to get into the panel sessions now, and we've got our first presenter, who's Daniel. Hey, Daniel, how are you?
Good, Phil. Yeah, thanks for having me.
Oh, well, Daniel, it's great to have you here. And of course, you're entering this investor conference with $16 million in your back pocket. So congratulations on the recent fundraise.
Thank you. It feels much better on the other side than trying to fight my way in and get it. But yeah, I'm enjoying my brief moment of agency.
That's wonderful. Well, talking of agency, I'll hand the keys over to you and let you take it from here, Daniel.
Thank you, Phil. Yeah, thanks everyone for joining me. So, within the time available, which is until 1 p.m., I'd just like to take you through three important points. The first is there are genes in the cell that can reverse age and rescue disease, but they're incredibly dangerous in their current form. The second thing is that there are now cell simulations available where you can run centuries of experiments in less than a year, and that gives you a lot more experimental power than you had until recently. And the last thing is that we're actually using this type of approach and finding new things that actually work in the real world. So it all comes together, and I can sort of go into each of those points in detail right now. So to begin with, what are these genes that can reverse cell age and rescue disease? So they're called the Yamanaka factors, originally discovered for another reason, which is a Japanese scientist called Shinya Yamanaka was trying to find a way to make an adult cell into a stem cell. Later on, it was shown that this same approach can actually reverse the age of the cell in the process. So this graph, I won't go into the detail, but the blue line is a robust measure of biological age called the epigenetic clock. And using the Yamanaka factors, you can reduce a cell from an age of 62 to an age of 0 in about 3 weeks. And yeah, this is sort of incredibly exciting. There was one point where it wasn't known if you could slow aging or stop aging, let alone reverse aging to 0. So this was exciting, but these Yamanaka factors are dangerous. They can induce tumors if you don't control their expression in vivo. So clearly something exciting, but also something dangerous. Secondly, these same factors can rescue disease in mouse models. So, in a mouse model of Hutchinson-Gilford progeria syndrome, which is a genetic um, mutation which causes accelerated aging, you can express Yamanaka factors. So, even though the mutation is still in place, Yamanaka factors overwhelm whatever the problem is in the cell and actually rescue phenotypes in this mouse and extend lifespan. So, you can see the difference between the red line and the blue line on the right hand side, which is in the presence of the factors, the blue line, in the absence of the factors, the red line. And these mice in the middle, which are expressing factors, are looking a little bit better than the mice to the left. So you have these genes, they can reverse age and they can also rescue disease. It almost sounds too good to be true. And it is too good to be true. There's this dangerous side effect, which is basically cancer inducing. But wouldn't it be nice if there was a version of this that was safe? You know, it's almost like the magic medicine. You could go into a older cell or you could go into an older and diseased cell and you could bring that cell back to sort of youthful, healthy functioning. So we believe we are within reach of a gene or set of genes that's capable of doing this. And the way we're going to get there, and the way we have been getting there, is something called cell simulations. So You can go into the black box of the cell with some of these powerful machine learning models, like the same models used in ChatGPT, and learn what's going on between genes and put that in the computer. And basically, you now have a virtual cell, and you can do hundreds of millions, if not billions, of experiments. So in a pilot experiment, we tested 350,000 different combinations of two transcription factors. And what you can see on the right is the change in the age of the simulation as we do all of those different experiments. So you can see most experiments age the cells by 2.5 years. But you also see in the green box, there's some experiments that reverse the age of the cell, and there's some experiments that really age the cell a lot more than we would expect. And what we do is we take those really exciting results from the simulation, we take them into the real world, and it works. We didn't expect this to work so early, but it does work. So what I'm showing you here is a new combination of genes. We're going to call it C0. And on the left is the change in epigenetic age, which is this robust biomarker of age. So C0 rejuvenating the cells by the same amount as Yamanaka factors. But crucially, on the right-hand side, when we do a colony formation assay, which is basically testing for this cancer causing problem, you see the Yamanaka factors inducing a colony, a subset of the Yamanaka factors, which are reported to be safe, also inducing a colony, and this new combination of genes not inducing a colony. So this is very exciting to see genes that are capable of the rejuvenation, but not with this terrible side effect. Even more recently, we've shown that we can recapitulate this with just a single gene. So we call this gene S1. We're able to reverse epigenetic age by 5 years over a 1 month exposure, so quite a long exposure for this particular gene, and we're not inducing colonies with this single gene. So a single gene is much more tractable from a drug development perspective. So we're very excited that there is even a single gene that's capable of this. So we'll see, how far that gets in validation. And this is the validation we're going through at the moment. We're testing things in fibroblasts to begin with. That's just the best system for doing lots of experiments. Later this year, we'll know if this works in multiple cell types. We'll also know if this works in a functional setting. So, can we take a fibroblast and show that functionally it's younger, not just using a biomarker? So we're looking at cell type specific assays like wound healing for fibroblasts, also cell type independent functional assays, which is basically the hallmarks of aging, like mitochondrial function and senescence and things like that. Importantly, we're also taking a baby step towards the world of therapeutics, which is running a fibrosis assay. So this is a disease-specific assay. We want to test whether something that's much safer can also rescue disease the way the Yamanaka factors can reduce disease. So we'll also have a readout, I think, by the end of Q1 next year on whether this can work in an in vitro disease setting. And then, there's lots of competition in the field that we work in. So, what's keeping us alive? What's our sort of existential technology? And it's really the AI tools that we've developed. So we developed something called a cell aging clock, which allows us to be confident that a cell's got older or younger. This took about a year and about £1.5 million to build a data set. And that clock can be used in simulation. So without this clock, you can't be confident you found something rejuvenative. We know many of our competitors tried and failed to create such a technology. And using this clock, we've been able to find 6 new ways to rejuvenate a cell that aren't as dangerous. And we have a sort of IP that's very strong around the gene therapies linked to those genes. So we don't know, there might be 200 of these genes out there, but right now the priority is to develop like an IP stronghold. And then we'll be in a good position to sort of build on top of that, but without a freedom to operate problem. We have the best in the world for cell simulations. Bo Wang was the author of the manuscript SCGPT, so using the same type of machine learning model to learn what's going on between genes and having a cell simulation as a byproduct. Brendan was the first to discover a single cell aging clock that was accurate. Lucas is the author of the most accurate aging clock. So I think in terms of the tools we need to complete the task, we have the best in the world. And what are we doing now with the money we've just closed? So basically, we're trying to fully de-risk the later drug development by finding out what all of these genes are, what's the modality that we can use to access those genes. So far, we've shown this simulation-based approach works. Next stage is to show that we can do this in vivo and rescue disease. We want to make sure we've got a IP stronghold and monopoly because we can leverage that later. And the reason I'm sort of giving the talk today is that already like immediately after the fundraise, we've identified additional milestones that will give us, you know, another level of value inflection. So we'd like to show that we can take an intervention and actually rescue multiple diseases across different mouse models, because that almost proves out that we've got something that could really go in multiple directions. And we want to map the risk landscape of age-linked indications because if you attain this technical goal, which is cell type agnostic, disease agnostic, you've now got the luxury of choosing between all of the different age-linked diseases that are out there, and you can choose the lower risk path forward. If you have this technical goal attained. So it's a big exercise we need to do, mostly research based, but basically map the risk landscape of all those age-linked indications, like what's the best model system, etc. So that's all I wanted to say today. If you want to contact me, dan@shiftbioscience.com. Please don't give my email address out to recruiters. I've got enough of those in my spam box. But otherwise, thanks for listening.
Well, Daniel, great presentation. Thank you. And a couple of questions, one from me and then one from our audience. Of course, you'll be very familiar with all of the arguments, positive arguments about validation of aging biomarkers in the space. And obviously, you've created your own. So is that a question you got from investors to sort of say, well, your results are great because they're using your system. How valid is your clock in the outside world? How would you respond to that?
Yeah, so there's an inherent conflict of interest in creating a measure that supports whatever goal you're seeking. So we have a single cell clock not to prove to the world that we found something, but to prove to ourselves that we found something.
Yeah.
Subsequently, you have to show that you work with a gold standard measure. You basically, you rejuvenate according to somebody's favorite measure that they're interested in. So slowly but surely, we're sort of going forwards, gold standards, functional assays, in vivo, disease models, just making this real for as many people as possible and what's real to them. So that a lot of that lies ahead of us, but getting an epigenetic clock to rejuvenate was something I've been trying to do for a long time. I ended up having to pivot the company to move away from an old hypothesis that wasn't sufficient. So getting to that milestone is a big deal internally, but ultimately we need to prove this out in functional assays and multiple cell types, and importantly in disease models.
Yeah, very exciting. And of course, your patent portfolio is going to be a big part of that as well, right?
Say that again, Phil. I missed that.
Your patent portfolio from those results is going to be a very big part of building moats around what you're doing as a business.
Correct. So as it stands, you can only make claims around the cell types that you've got data for. We're going to be trying to do multiple cell types, and there'll be cell type linked diseases. But if we can show a diversity of cell types, we can actually make quite a powerful claim across age-linked disease. So that's a priority from an IP perspective to show multiple cell types to make that type of claim.
Yeah, very, very exciting. So, got a question from Anna Baroni. She says, how do you envisage the treatment with this gene? Are you considering EVV or LNP? And do you have any ideas about the regimen and the costs for patients? Which, of course, is probably a way out from where you are at the moment, but interesting question.
Yeah, modality is very big question. So we're working with transcription factors, which are the least druggable part of the cell, which is almost sadistic working on that if you're trying to develop a therapy. We're going to make the simulations as good as possible through these sort of iterative wet lab, dry lab loops. And we're going to then branch out to the druggable universe, which is the whole genome, simulate all combinations of two genes. And ideally, you find two kinases you can inhibit, but we don't know what the biology is going to allow. So we need to, it's really biology led at this stage. The fastest way to find out is just to complete the exploration.
Yeah, well, exciting times, Daniel. We love watching your journey, so looking forward to the next round of news coming out from you guys. And thanks so much for joining us today. Really appreciate it.
You're welcome. Thanks everyone for listening.
Great, thank you. So we're now going to move on to Kevin Slawin, who's the CEO of SENOLYTIX. We would call you guys a level 7 and potentially a level 8 company, Kevin. And of course, you've recently rebranded and you're kind of emerging from stealth. So you're focusing on the xenotherapeutic hypothesis of aging. And that's a terrifying amount of slides to get through in your time. But I'll hand over to you and good luck.
Uh, Thankfully, most of those are in the appendix.
That's great. Over to you, Kevin.
Can you hear me, Phil? Okay.
Yep, we can. Yep, all good.
Okay, great. So I appreciate the opportunity, Phil and Master Investor, to present ES Senolytics. our xenotherapeutic company that's goal is to improve health span and increase lifespan. Just getting through the usual legalese. So we're working in geroscience, which is the study of mechanisms that make aging a major risk factor for common chronic conditions and diseases of aging. And geroscience is really at the intersection between aging, disease, health span, and lifespan. The primary goal of geroscience is to extend the healthy years of life by targeting underlying biological process of aging. And there was a very nice a paper recently on the goals of geroscience that you might want to access. Now, our company is focused on something a little more straightforward than perhaps Yamanaka factors, which is fascinating. And we're working on what's called the xenotherapeutic hypothesis, which says that senescent cells, also known to the layperson as zombie cells, which can be identified in tissues by either high beta-gal expression, which is blue staining with X-gal, or other immunohistochemical markers like P16 or P21, that they accumulate in various organs with age, and that these senescent cells secrete a pro-inflammatory set of factors called the senescence-associated secretory phenotype, or SASP, and that these cells and the SASP then leads to a process called inflammaging, or an inflammatory process in the body that's in no way linked to any kind of infectious process. It's just inflammation associated with and causing aging. Now, in this hypothesis, the accumulation of senescent cells as we age is the cause of many aging-related problems, if not most. So if you go through all the major organs of the body and the brain, you get cognitive decline, Alzheimer's, CTE, the heart, kidneys, etc. We see all these aging related diseases that accumulate with age that are directly associated with the accumulation of senescent cells in the body. And there's a very extensive proof of concept set of studies in the peer-reviewed literature that clearly shows that if you can eliminate senescent cells, selectively eliminate them from the body, you can reverse all of these aging-related diseases. And in fact, if you're interested in seeing this body of literature, you can see in the bottom right there, I've curated them on our website in the media center there, and you can click on any organ and see what I'm referring to. But in the brain, clear studies show that if you eliminate senescent cells, you can see cognitive and memory improvement. In the heart, kidneys, you have a reduction in glomerulosclerosis, etc. And so I think the proof of concept here is quite extensive and very solid. Not only can you reverse these particular aging-related diseases, but there's also clear evidence of both the extension of a healthy lifespan or health span and even lifespan, and a reduction in death from cancer. In simple terms, how would I explain this process to the layperson? Well, let's look at it like a drain. During our youthful years, we don't have a lot of senescent cells in our body, and the immune system is quite good at clearing them, so there aren't that many present. Your organs function smoothly, like a free-flowing drain. As you get older, the immune system's rate of senescent cell clearance is mostly keeping up with the rate of formation, so there's still not that many around, and the organs continue to function relatively smoothly. But as we continue to age, senescent cells will continue to accumulate, the immune system becomes less efficient at removing them, and the inflammation caused by the senescent cell itself causes immune system impairment, cellular stresses associated with aging, increase the rate of formation of these senescent cells, and this leads to their progressive accumulation. And now you start to see organs beginning to malfunction due to this adverse cellular and tissue microenvironment. So look at it like the drain is starting to get clogged, the sludge is building up, and you're starting to see some dysfunction. At almost its latest stage, in advanced stage, we see widespread senescent cells causing inflammation. It reaches critical levels. You get all kinds of diseases related to that, like cognitive decline, cataracts, etc. The drain is clearly clogged. The water is overflowing, and the bathroom is an entire mess. And so in xenotherapeutics, you you give an episodic senolytic therapy, which cleans out or removes these senescent cells over a defined therapeutic time period. You remove them back to the time when there were few senescent cells again. It allows the organ functions to return to an efficient manner. You can monitor the level of senescent cells in the body over time. And when they accumulate it again, you just can retreat. So you don't necessarily need to treat continuously. You can have an episodic therapy, which can reduce the risk potentially of side effects. So, as I've said, it's becoming more and more clear that the accumulation of senescent cells in the body over the lifetime, I think there's no controversy that it is, a contributor to aging, but in our opinion, it is the primary driver of aging, including all the problems associated with aging, as I've mentioned. And that there's clear, compelling proof of concept in animal data that eliminating those senescent cells has beneficial effects in eliminating all of these diseases with a single gerotherapeutic approach. Now, at the recently held ARDD meeting, which is a meeting of all the leading aging researchers in the world that was held in Copenhagen in August, one of the leaders in the field basically said that our greatest hope in developing these types of medicines is to see what's already approved and try and repurpose them. So I feel that's a generally pessimistic view of where the current state of the field is. Now, I've been working on this since a little over a year ago when I did this study, which I call Self-15, where we took naturally aged 75-week-old mice, which is approximately equivalent to a 50 or 55-year-old human, and we treated them over 8 weeks with some peptides that we had identified that appeared to be effective senolytics. And then we monitored their tissues. We sacrificed them and looked in the tissues to see the number and extent of senescent cells in the body. Now, since then, we've done a fair number of additional studies. We're up to cell 27 here now, where we've added another peptide, 2107 to 2101 and 2105, which are our senolytic peptides. We do extensive phenotyping of these animals and evaluate them. And this is an ongoing study, for example, where we're treating these aged mice with these peptides and then evaluating them in a number of ways. We have a room at our facility that runs 7 days a week in phenotyping these mice with a number of instruments in the room. We have a motorized treadmill, a rotor rod, a maze, a grip strength, a DEXA scanner, all evaluating these mice that we're treating with our senolytic peptides. This, for example, is a rotor rod. It's all automated, so you put the mice on and you get the data readout, which is free of any observer bias. Now, I submitted an abstract with some of our data to the International Conference of Frailty and Sarcopenia, which is going to be held in March of 2025 in Toulouse, France. The abstract's titled "Novel Senolytic Peptides Alleviate Sarcopenia and Frailty in Naturally Aged Mice by Targeting Senescent Cells." And I plan to unveil some really remarkable data at that meeting. But because it's an academic meeting, I'm trying not to reveal the results of our data until then. But I will give you a little bit of a sneak preview, or if somebody's interested in this more and wants to go under CDA, we could show more. But in summary, in the two studies I just showed you, cell 15 and cell 27, I think we have clear evidence that we've discovered the first gerotherapeutics that are aimed at an aging-specific target. Now, what do I mean by that? So, first of all, these studies were all performed by my talented team at SENOLYTIX in Houston. They're all performed in naturally aged 75-week-old mice, so it's not a transgenic model or some other artificial model. And as I've said, a 75-week-old mouse is roughly the equivalent of a 51-year-old human. We have 3 peptides that we've tested extensively. 2 of them we're planning on developing clinically. That's 2105, 2107. There are proprietary senolytic peptides. They target senescent cells for elimination with about 8 weeks of treatment. So we've shown now, and I've shown you data, that senescent cells play a widely recognized role in aging. And if you target them, you're avoiding targets that play a diverse and key role in normal cell biology. So we're not targeting mTOR or BCLX or even the Yamanaka factors, which I applaud Daniel on his work there. But as he noted, there's risk that he's trying to mitigate by improving them. We're just targeting senescent cells, which play a very limited role in healthy biology. And our therapies only require episodic therapy, so not continuous. And in summary, what I'm not showing primary data except for one sneak preview, but in summary, what we've established now and what I'll be presenting in March at that meeting is that our peptides effectively and safely eliminate senescent cells. More than 75% of senescent cells in an organ can be eliminated within 8 weeks of therapy. That we also show a reduction in the plasma circulating levels of cytokine components of the SASP in response to removing these senescent cells. We show tissue morphometry improvements like the intermyocyte space in muscle, the adipocyte area in treated mice, all improved. We show prevention of weight loss that's typically seen with age-associated sarcopenia. And remarkably, we show preservation of lean body and bone mass at the expense of fat mass in these animals. We show improved performance on all of the apparatus I mentioned, the motorized treadmill, the four-lever grip test, the water-motivated stone T-maze, and the rotor-rod. Now, I told you I'd give you a sneak preview. So here's just one piece of data from cell 27 data. These are 75-week-old mice that were treated with these 3 peptides for 13 weeks, and then we did DEXA scanning on them. And I drew a line here through the lean body mass percent of the negative control saline mice, because it's a little hard to see the data, but you can see that remarkably, after 13 weeks of peptide treatment with the 2 peptides that we're developing clinically, 2105 and 2107, we see a 20% reduction in fat mass and almost a 10% increase in lean body mass, including an increase in bone mass. So this is important. I don't know if you saw data recently from the Amgen compound in clinical trials where there was some concern over loss of bone mass in the high dose group. Here we're seeing preservation of bone mass and lean body mass at the expense of fat mass. Now, you might ask, was I surprised to see these results? Well, I really wasn't surprised. And why not? Because in 2017, Farr et al. Already had shown that if you eliminate senescent cells in this genomic ablation model using the INK-ATTAC suicide transgene, if you eliminate senescent cells in aged mice, you would see improvement in the bones. So I already knew that if you could just develop a therapeutic that could do the same thing, you could see these results. Now, as a very quick side note, the data that was generated here using the INK-ATTAC model was developed using technology by Baker et al. That actually my group had invented in the past that we used to launch Bellicum Pharmaceuticals, which was one of my first companies, one of the first CAR T-cell companies that we took public in 2014. We had invented Caspicide, which was a cell therapy safety switch. It's the only validated switch in humans. And that's what Baker et al. And Kirkland used for their seminal papers, and everybody else who used that model to show that elimination of senescent cells leads to beneficial effects. But that's actually our technology that he was using. And so we're actually developing it now as a gene therapy in a separate company. So that's how I got into the field. So just to finish up here, I think senescent cells are the culprit in a lot of aging-related problems, but few drug developers are pursuing what I think is a clear target. I think mostly because it's been very difficult to find something that could selectively eliminate senescent cells from the body, both safely and effectively. But we've discovered a number of senolytic peptides with the remarkable ability to effectively and dramatically eliminate senescent cells throughout the body, including in the brain, with no apparent side effects now out to 14 weeks of therapy. And so we're going to take this forward and try and jumpstart the entire field of xenotherapeutics by performing 3 phase 2 clinical trials simultaneously with 3 different primary endpoints using 2 different peptides, the 2107 for whole body, 2105 for brain. We're targeting obesity and glucose metabolism because we've noted that we can preserve lean body mass at the expense of fat mass, sarcopenia and frailty, and cognitive disorders. All of them have different primary endpoints, but we're synchronizing the secondary endpoints across all of them, similar to what Daniel was saying, to try and get a broader scope of a gerotherapeutic claim as opposed to individual diseases. And we're currently raising 100 million Series A to do this ambitious program, and we're hoping to close it by the end of the second quarter. So 100 million targeted Series A. We've raised about now close to 10 million convertible notes. We have a number of peptides that we're taking forward. And if you're interested in participating in this institutional round, you should contact our investment banker, John Andreas, Evolution Venture Partners. And then just finishing up here, I'm the founder, chairman, and president of the company. I founded Bellicum Pharmaceuticals, which is the first CAR T-cell company, took it public in the past. And I've been a very active researcher in my previous career. So this is really a science-based company. Jody Aiken is joining us, who was the founder of Hawthorne Health and who got the TAVR approved for Edwards Life Sciences, and she's really great. And Kayvon Nambar, who's a very well-known person in our field. So that's all I have. I'm happy to talk to anybody who communicates with me if they're interested in this round and go under CDA. I'd be happy to share our really remarkable data prior to the March meeting. But in March, we'll be presenting a very extensive set of data that I think is going to be groundbreaking. Thank you very much.
Kevin, thank you. Well, obviously, there's a lot to unpack there, as you say, very ambitious. So I'm glad you're going to be joining us for the panel session at the end. So I'll keep my powder dry on some of those questions. And thanks for your presentation today. Really good.
Thank you.
Cool. So we're now going to move on to somebody who doesn't really probably need much introduction to many followers of Master Investor. Greg Bailey is one of the founders of Juvenescence. And as we all know, Juvenescence has been at the forefront of the longevity field for some time, especially since 2018 when I was cycling around Norway. So Greg's here today. Hey, Greg, how are you?
Good, thank you. How are you, Phil?
Yeah, really great. And just looking at your website, as I would always do, just to kind of get a feel as to what are the right questions to be asking you, I was delighted to see that you've got, in 2025, you're on track to have 5 therapeutics in either phase 1, which is safety, or phase 2, which is safety and efficacy trials with disease intervention. So that's big news. Should we unpack that? That's brilliant.
Wherever you'd like to start. But yeah, we're truly excited.
Yeah, well, I guess what would you say? I mean, obviously, looking at the asset, let's take the one that's at phase 2, because obviously that'll be something that you'll be telling investors about your progress on that. So what is that therapeutic, and where are you targeting it?
I presume you're talking about Longevity and the liver transplants?
I would, yes. Yeah.
So, I mean, it always amazes me how scientists come up with ideas. So the institute at McGowan Research Institute at University of Pittsburgh is the inventor of the liver transplant. And the problem is, and I'm sure it's similar numbers for Europe, there's about 200,000 Americans who are liver failure. There's 8,000 livers that are donated a year. 2,000 can't be harvested in time and reach the recipient or fit as far as immunological status. So what they came up with was the idea of taking these 2,000 livers, dividing a liver into 75 aliquots, proliferating it, and injecting that into the lymph nodes, the paraduodenal lymph nodes, for those of you who are scientists, around the liver. And in 400 animal studies, they were able to prevent the animals from dying from liver failure. We've now dosed 4 patients without side effects. A huge discrepancy in the transplant, which is 8 hours, $800,000, versus a 15-minute endoscopy and day surgery in and out, and a dramatically different price point. And obviously 2,000 livers times 75 would be 150,000 patients you could treat. So yeah, amazing. And I'm always curious, Phil, how they came up with the idea of injecting it into a lymph node, what other places they decided to try first.
Yeah.
But anyway,
and I know there's a trajectory, Greg, for that science that's just going beyond liver disease, right? So there's a pathway for this to become much more backed into the longevity agenda, as I understand it.
Yeah, I mean, there's no reason you couldn't do beta islet cells for the pancreas with the potential to reverse somebody out of type 1 diabetes. Additionally, obviously post-COVID, we're all too aware of the fact of immunosenescence, the aging of the immune system. Could we take the thymus, re-inject it into lymph nodes, and regenerate, the elderly's immune system? And what really surprised me is they can also do it with the kidney, because I'm trying to figure out how they, connected to the ureter, but they have figured out a workaround for that as well. So very, very exciting.
Yeah, and of course you've got other things in your portfolio too, which are all very interesting. I'd like to talk to you about one of your assets in just a moment. But I guess, like many organizations, you're capital intensive. So how have you found because it's an investment show, right? So how have you found the investment marketplace over the last couple of years? I mean, it's been tough for a lot of people. I'm sure you're not immune to that. But how are investors responding to this clinical progress, and likewise the work that you're doing in the broader field of longevity?
Yeah, it's been torturous last 2 years.
Right.
Definitely a biotech winter. And understandably, if you're looking at investments and you can get, 5.3% on a T-bill, why gamble, here, particularly when you're used to zero on any interest rates. So, we need to recalibrate. And I think we need a few home runs, and then you're going to get FOMO. And then people will rush back in. Obviously, BioAge has been a real feather in the cap of the sector. It's doing well, robustly trading post IPO. So I think things are changing, and the drugs are going to come fast and furious now. I think we're at a major inflection point. So any of you investors who are listening, this is a golden opportunity because the valuations have been so badly beaten up. So we've had a tough time. I think we have now turned a corner as well. Richard Marshall or David Gill at Juvenescence can talk to you about that. But I think that we're going to be able to get to our next, major capital raise, which is a further 100 million. And
Great. Well, congrats and good luck with that, Greg. And I guess
thank you.
You've already referred to something that I feel is very interesting, specifically from your portfolio too, because you've got this asset GDF15, which is addressing muscle wastage. Now, of course, we're all aware now through the GLP-1s, Wegovy, Ozempic, this whole weight loss craze, this whole phenomena in our industry, which is kind of a stepping stone to longevity, right?
100%.
Yeah, but
first anti-aging drug, Ozempic.
Yeah, so I mean, it's kind of like, well, I'm interested to know, is that asset going to be potentially backing into that class like BioAge, for example, with their sarcopenia?
Yeah. Lilly, Novo Nordisk, Viking, all of them are scrambling to figure out this element that 15 to 20% of the weight loss is actually muscle.
Yeah.
And how do they mitigate that, which is not tragic in a young person, but it's hugely problematic as we age with sarcopenia. So, I think it's an absolute fit. It's also a fast follower. Pfizer is using GDF15 in cardiovascular patients. And since it's a 400 patient study, they must have seen a heck of a signal to do a phase 2 400 patient study. So we've got to get that one into the clinic as quickly as possible and follow along. And then, as you say, the element is anything that can mitigate this muscle wasting will be warmly received by the people who have the GLP-1s, the GLP-1s.
Yeah, because I guess it's kind of that moment that, I mean, I talked about a GPT moment. It's not going to happen overnight. This is going to take time. But with Juvenescence as a prime example, with these assets coming through the clinic, working on these aging drivers, we're getting very close to the next aging therapeutic, right? Beyond GLP-1s. And of course, this is the time where we're going to see that explosion in the industry that we've all been waiting for, right?
Yeah, and for the investors, I think it's a major inflection point. We have 2 drugs. One just finished a human trial. One is in a human trial, which, if we're right and it's not toxic, will add 10 healthy years to your life on a reasonable human model that shows that if you knock down that pathway, you see that sort of change in health span, which is the most important thing, I think, for all of us. And so, yes, and I'm sure there's lots of people you're interviewing and talking to who are similarly working. Obviously, the 2 people who've been on the call already with the SENOLYTIX and the Yamanaka factors. So huge moment for us and enormous for investors, because the one thing about the GLP-1s, I mean, just about any analyst you read talking about them says it's $150 to $200 billion a year market. What, Phil, would a drug that gave you 10 healthy years, how big would that market be per year? Give me a number.
There's probably got too many zeros for the call, right? But I guess at the end of the day, this is going to happen. And I guess it's quite interesting the Juvenescence approach that you have, because it's a kind of mix of different business models. And I know
Very much.
in the past that you've been working in, grass generally regarded as safe assets, and you've got your ketone products. And it's kind of interesting to me that you're taking your science into the therapeutic sphere, into the clinical sphere, but likewise also into the consumer marketplace. So is this something that you're interested in pursuing, or are you going to be divesting these types of assets to continue in therapeutics, or is consumer sort of part of your game plan?
Richard Marshall and the board will obviously dictate it, but my personal instinct is I think everybody who's listening in, all of our panelists and yourself as well, will know that, presumably you're going to have to take products for an awfully long period of time. So they're going to need to be incredibly safe. So I'm going to see a blurring of the line between natural products and pharmaceuticals, supplements, foods, whatever, medical foods, whatever you want to call it, because it's going to have to be so safe. And as you said, with your own supplement opportunity that you're pursuing, that this is going to be a huge market. And people always ask me, is this going to be only for the wealthy? Phil, if we have a supplement that we can make for 5p, 5 cents, whatever currency you're dealing with, and you sell it for $1 a day, I'm wagering that there's over 1 billion people globally who could afford that price point. If it's going to significantly change my health trajectory and how long I live healthy, you make $365 billion a year.
Yeah.
Now it's not going to be one drug, but these numbers aren't crazy, and you don't have to charge as much money as the GLP-1s to get to home plate. So yeah, this is a huge, huge opportunity for the sector. And as you say, there's a number of supplements that have, drug-like qualities. By the way, hopefully the FDA didn't hear that. When I say drug,
yeah, I think we all get what you mean. That they're very powerful, and they do have clinical application, right? And I guess the very interesting thing with some of those assets is, will they stay at the same price point if they go into a therapeutic pathway? Because obviously that's what we want, right? Because as you mentioned, there are all these people in developed societies that are aging. There isn't the population pyramid in these countries to support those future populations, those aging populations. I guess a question for you, and it's an interesting question that also came in from Sophia. So when you're speaking to investors, are you making a sort of black and white commercial discussion with them, or are investors with their ESG, CSR, whatever their perspective is, are they taking a holistic view on what these are going to do to society as well?
Originally, most of the money we've raised has been from ultra high net worths, family offices. You and I have kidded about it. No surprise that wealthy people want to live longer. They're having a good time. They want to stay here. So I think that they have, personal reasons. And then there's some family offices which clearly have interest with respect to their sons and daughters and family, because these drugs hopefully will be priced for everybody. So I think you do see both. And then you have the institutions, and they're supposed to deliver a return to their investors. So it's quite a wide spectrum. I think the institutional players are gradually coming back to this. They want to see human data. So that's a huge dilemma for all of us on this call, and our industry in general, is they want human data. And so that we got to get there, which is why, as you said, we want to have 5 in the clinic next year.
Great. Well, I think tangentially we've answered Sophia's question. So, Greg, I've got another question, which is probably a little bit of a down one, but it's an up one as well. I had a look at your site, and I saw that really there'd been very little communication activity over the last year or so. So that tells me that you guys are in the tunnel, and there's something exciting, we would hope down the line. So is there anything you can kind of share with us as to how you feel about 2025?
I think it's a huge inflection point for us and for the industry, as you and I have just been discussing. That human data. The extraordinary thing about we have the product is a PI1 inhibitor, and what we know is there's a population that has a heterozygous SERPINE1 gene, which means their PI1 is diminished. Those people live 10 years longer than people in their community, and it's a very tight religious community. So they're eating the same, they're sleeping the same, they're working out the same. So we have created a drug to knock down the PI1 pathway. So The amazing thing about that was in a phase 1 trial, it's usually just to prove safety, but it also is a biomarker. We can actually measure PI1.
Yeah.
So partway through this phase 1 trial, I will know if we have a therapeutic dose that's not toxic, that knocks down PI1. And that if I'm right, and the team is right, Juvenescence, this adds 10 healthy years.
Mhm.
And then we go back to that number I just asked you, how much money will that generate per annum if it's doing that?
Yeah. Well, Greg, obviously we could go on all day. I love talking with you about the scale of Juvenescence, which is really phenomenal. So you're going to be around for the panel session at the end. So I really appreciate it, Greg. Thanks for joining us so far.
Thank you, Phil. Always a pleasure. Take care.
Great. Thank you. So I feel I've answered Sophia's question. We can go through other questions. Please keep putting them into the Q&A channel because we're happy to have them. So now let's jump into what we call the longevity now side of the industry. Where are the current ways to engage in longevity as individuals, which we all should be doing, and likewise, where are the opportunities for investing? So we've got Deepankar Nayak now from Deep Longevity, also known as Deep. So I don't know whether Deep Longevity was named after you, Deep, or was it something that happened by osmosis?
It's just a coincidence, Phil. Deep Longevity was existing before I joined it.
Got it. Great. Well, Deep, over to you.
Thank you so much, Phil. Delighted to be here. I'll share my slides and hope everybody can see it.
Yep, we've got them.
Yeah. So if you speak with the people that know me, they'll tell you I'm always talking about deep longevity, but I know time is scarce today, so I will be succinct in my presentation. So Deep Longevity is a vertical SaaS AI-driven preventive health tech company backed by patents and IP. Our core products that you can see on the screen now are aging clocks, using which we predict biological age and make recommendations to improve health. There are four aging clocks that we are commercializing today. They are blood age, mind age, biometric age, and epigenetic age. So how does the business look like? The core products, so essentially, first of all, I'd like to mention that Deep Longevity is a B2B2C company. So we are working with enterprises who own their employees and customers and patients who use the aging clocks. The clocks are available through APIs that can easily integrate with apps and websites. And for clinics or organizations who want to have a low tech footprint, they can access the clocks through the branded SaaS platforms called as SENOLYTIX and SENOLYTIX Gold. What we offer is biological age prediction, a deeper understanding of health, personalized recommendations, all of this neatly bundled in health summary reports. Now we are already seeing, and that will give you an idea of the potential of this technology and the addressable market that's available to us. Being on the side of preventive health, the technology actually works across industries. We see insurance as an industry that is ready for disruption. Our technology can help a lot in customer engagement, as well as work with underwriters to come up with new pricing strategies. Employers will have unique data, unique statistic to take to their employees and focus on preventive health. Providers for us are the low-hanging fruits. There are many physicians and doctors all over the world who are taking to longevity and taking the message of longevity to their patients. And most importantly for them, the technology comes as something that enables their revenue. It helps them grow their business. And we are working with them, many of them in different parts of the world. The input to the aging clocks are various diagnostic reports. So we have a natural synergy with diagnostic companies. Just before this event, I finished a meeting with a couple of doctors with whom I was discussing the possibility of really scaling our technology for public health. It can be deployed on the cloud. It is eminently scalable. And using AI, we can personalize at n = 1 level. Consumer health companies are looking at showing the efficacy of the products, coming up with new subscription plans for the supplements, the vitamins, the nutrition products, and they are finding our technology is something that can be quite useful. And finally, we are building a white label longevity platform for those companies who want to go directly to consumer. They have the business ready, they want to focus on the consumer, and they don't want to focus so much on the tech, which we can build for them. Our revenue comes from two parts, really simple. The clocks are available with an annual subscription, and then there is a pay-per-use model where companies pay for every prediction that they generate. So tying this to what Greg was saying before, if you look at the billions of people out there who'd like to know their biological age, who'd like to improve their age, and if you think if they're ready to pay a dollar to know this information, we can see how big the market can potentially be. So let's dive a little deeper into the aging clocks. Our most popular aging clock is blood age clock. Blood reports are there with everybody has them, but it gives them very little information. We can take that data and then we can bring in a lot of insight along with biological age prediction. And if you see the panel of biomarkers, we use standard biomarkers which most people look at when they are doing an annual health checkup. These are lipids, kidney status, clotting status, glucose, white blood cells, proteins, liver function, iron status, red blood cells, minerals. Nothing exotic here at all. What we give back in return is a blood age summary report, which along with the biological age prediction has organ health scores. It gives weekly diet plan and also gives a weekly exercise plan. Along with that, we are providing recommendations on lifestyle, and we are also talking about supplements when we see it's really needed. Going to mind age clock now. Our approach to mind age is from a preventive standpoint. Now, there are hundreds of mental health applications out there which are focusing on one condition on the other. What we are saying is we are looking at mental health like the way you look at exercise and sport. You do that because you are healthy, not because you are sick. But there are very few people who are doing something proactively about their mental health to improve their well-being and resilience. So the way MindAge works is we have a proprietary questionnaire, which the answers to which the AI takes and then creates a psychological profile, which is mapped to what we call an island of emotional stability. The AI at the same time determines what's the higher level of well-being that the person can aspire to. It is entirely possible that there are more than one people who have the same starting or ending point, but they will have their unique pathways to reach there. And therefore, there could be infinite ways how you can reach from a lower plane of well-being to a higher plane of well-being. The psychological profile is built across 6 well-being parameters of positive relations with others, self-acceptance, autonomy, personal growth, environmental mastery, and purpose in life. So the AI is looking at the scores across these well-being parameters and then gives recommendations which puts the person on the path to improving their well-being and resilience. In our reports, we take the effort, and that goes for all our products, to actually explain to the layman what exactly we are trying to do here and how to interpret the information. So we'll explain what is a well-being parameter, what does a high score mean, what does a low score mean. So when you see that score, you can introspect, you can have a discussion, and you can then align with the score and think that, okay, this is something that speaks to my personality, and these recommendations are something that I can actually go ahead and execute. Epigenetic aging clocks are very popular and becoming increasingly popular. We are one of the first ones to launch an epigenetic aging clock in the market. At the time, it was one of the most accurate ones. It still is, or amongst the most accurate DNA methylation clocks. It's also very robust because I think we are amongst the few providers that are looking at a large number of epigenetic profiles. We have about 1,000 genes across which we look at the methylation and then determine the epigenetic age. But for this, we are working with data only from Illumina arrays. So quick look into SENOCLOCK and SENOCLOCK Gold and SENOCLOCK Consumer, which is our SaaS platforms. So we have put all the aging clocks that we have built under SENOCLOCK. The predictions are generated almost instantaneously. The platform is highly scalable. It can be used for hundreds of thousands of users or a few hundred users, depending upon where a business is placed. SENOCLOCK we built keeping privacy at the core of the business. So SENOCLOCK works in a completely anonymized fashion. The only input we need along with a set of biomarkers is age and gender. We don't need any other personal information. And we don't store any other personal information. SENOCLOCK Gold, on the other hand, caters to the need of users who want to actually track how their health is progressing over time. So we are taking this to employers as well as clinics who want to give access to their employees and patients and users who would log in, who would track how their organ health score has progressed from the previous test to the latest one, how their biological age has moved, how their well-being scores are changing. And then they can relate this to different things that's happening in their life. They can relate this to different events, interventions, whatever actions they are taking to improve their health, and then understand why their health is changing based on what is happening with their lives. What we have also done with SENOCLOCK Gold is we have created a set of reports which allows organization to have an aggregate view of the population. So in case of employers, they would know across age groups and gender which population is doing better than the rest, and therefore identify pockets which needs more resources than others, and then direct their efforts towards helping that section of the population. The platform is configurable. So in case of employers, obviously they won't be able to see the information of the employees. But in case of clinics where the doctors would like to and should have access to the patients, then that access can be enabled. With SENOCLOCK Consumer, our goal is to build a longevity platform which has all aspects of a patient health record, a patient diary. It'll have information about the medical history, about lifestyle information, about supplements that a person might be taking, along with information of pertaining to all the aging clocks that we have. And all of that would be put together, something that they can export information from and also share with their physicians. This platform would be available as a white label longevity platform for any business that wants to go to the market and do it quickly. Finally, Deep Longevity is revenue generating, has been for a while. The customers are global. They are there in Europe, in the US, in the Middle East, in Asia, and increasing. So we are at the stage where we want to build more. We want to reach out to more markets, get more customers, build more aging clocks, build more functionality and features with our existing products. So we'll be very happy to speak with any investors who are looking at this space. That's all. Thank you so much.
Thank you, Deep. Well, obviously, you're backing into a very interesting aspect of this whole industry, right? Which is, can we measure age and can we make age plastic and roll backwards? So you're going to be joining us for the questions session at the end. So I've got a few questions I'd love to lean into with you. So thanks for your presentation. Really appreciate it.
Great. Thanks for having me here, Phil.
Pleasure. So we're now going to move on to our corporate partners. We work with Founders Forum as Longevity Technology as part of our work that we do in the event space. And we're joined today by Sara Pazin, who is actually at the front of Founders Health. So Sara, how are you doing?
Oh, there we are. I'm good. How are you, Phil?
Yeah, great. Well, I saw you running around yesterday, so I guess you're probably one of the busiest people in longevity, but love to hear about what you're doing at Founders Health.
Yeah, absolutely. So I can actually share a few slides.
Perfect.
Just one sec. I think, I'm the CEO of Founders Health. Founders Health is a longevity business by the Founders Forum Group. So as Phil mentioned, we're doing a lot of different collaborations together, including running some longevity conferences, with one actually coming up pretty soon in Singapore next year. But kind of in the conversation of all of the things that we're looking at, it's where does so much of this stuff live? And really, it's going to be, it's these longevity clinics that are sort of starting to pop up everywhere, but really it's going to be a quest of trying to build this right. And our view is there's really going to be a few leaders in the space that are really going to get it right. And I think everybody is putting such incredible efforts in building it out today, but we're still in such a learning point where we're kind of trying to test and see what does and doesn't work. So at Founders Health, we are building a network of longevity clinics that are powered by tech-enabled care. And just a quick quote by the Dalai Lama was, "Man sacrifices his health to make money, but then ends up sacrificing his money in order to recuperate his health." So my question to you is, how much do you actually invest in your most valuable asset, which is your health? So obviously we know today's healthcare is a sick care model. We are only really engaging when something is wrong. And the truth is, when we look at us as individual people, we don't actually know or understand our baseline, our health baseline. And then, by then you go into a system and it often ends up being too late. These chronic illnesses progressing silently over the years and always kind of band-aids to try to fix it, but we don't really have a complete view of what it is that's going on with us. So at Founders Health, we're really focused on this preventative and proactive medicine approach. And it's by understanding your baseline today that we can actually help you improve and maintain and then optimize your health for the next decade and beyond. So what sets Founders Health apart is we're really here before you actually need us. And because the reality is that when you're 55, your health may seem fine, but without those right preventative measures, the next 7 years are going to be telling a different story. And, with us, you really have your care in your pocket. Whatever that problem is or what that need is, we work with you to get to the bottom of that. And we're really 100% focused on client outcome. So how are we doing it? Well, we have one of the most advanced physician and practitioner teams at our disposal, and we are working with select partners to be able to build out this complementary tech aspect. So really, we are a hybrid model that focuses on the premium longevity clinic side and then the tech-enabled care. And we know that it's important because, we've seen in the space, there's a lot of over-indexing on one side versus the other side. But what we're really trying to find is that complementary balance. And so, while we do employ the tech and precise measurable data to be able to really enhance people's health progress, we really never want to lose sight of what matters most, and it is having that human touch and expert care at our core. So in terms of our team, I sort of have at the top our leadership team. It's really a world-class experts in building, operating, scaling businesses. And of course, we have our founding partners being Brent Hoberman and Carolyn Dawson from the Founders Forum Group. And then that is combined with the world's leading experts in longevity medicine and anti-aging. So today we have 6 physicians and we are growing that. And these are physicians who specialize across psychiatry, across functional medicine, oncology, internal medicine. So really we have a wide breadth of expertise. And then of course, supported by our multidisciplinary expert team experience. So we have performance and recovery specialists at the lead. We have nutritionists, and we're actually bringing on board a mental health expert as well. So I can walk you a little bit through of like how we actually deliver this integrated care. In my view, the sort of the initial entry point is that it's almost back to basics. Yes, we're developing the tech, and yes, I know everybody's moving at hyper speed to get a lot of this built, but it really starts with just a conversation and understanding that client. We put the client at the center every single time. They meet with the full team, and then we really work to understand your needs, your issues, your goals, and then we go through full medical history and full medical results to be able to put together essentially an aspect of a digital twin where we're able to present to you, this is where you are at, and this is what the trends are showing before we've even recommended what your next steps are. So once we actually have that picture, do we actually then say, these are the additional diagnostics that you would need in order for us to obtain the additional data to be able to build out this baseline for you. And then at that point, we can suggest to you the appropriate membership. So it is a membership-led business. We will initially sort of be seeing clients in a mixture of memberships and pay-as-you-go. But the idea is that under a membership, we're able to work with you along that entire journey to be able to intervene with the necessary therapies, medications, and support. And it really just lets you have the entire medical and wellness team at your disposal for that journey. And, we've already started seeing clients. So the clinic is set to open early January. So we have a medical aesthetics business today that we've acquired. So the clinic is in Belgravia. It's going through a refurb right now and a rebrand. So when we launch early next year, it will be under a new name. But we have already started seeing clients in the offline environment through our physician and practitioner teams. But yeah, we're ready to go, and we just have a few final bits to do, and we are going to be opening it to initially the Founders Forum community. So we're very lucky that we're powered by the Founders Forum group. Obviously, we know that the clinic business is a difficult business today, and we know that we're going in with price points that are more catered to kind of affluent and high net worth. But we are opening the waitlist initially to be able to learn from this process with people who are in our community. So through Founders Forum, we have access to over 15,000 industry leaders, CEOs, founders, investors, everybody working across tech, healthcare, government industries. But at the end of the day, these are some of the leading minds, and these are very high performers. There's burnout, there are mental health issues, there's gut problems, there's insomnia. And these are really people who are looking to optimize and kind of biohack their biochemistry, learn more about themselves, and looking for a team that can help them achieve this. So we've been having these conversations for almost 2 years with people within our network with different founders. And it's something that people are really looking for, but struggling to find where the right offering is. So we really are hoping that we're able to give that to this network initially while we sort of learn and refine. So we will be opening our waitlist very early January, and then there will be a public launch in 2025. And then the last bit is that we have this, we've sort of developed our foundations with a very strong clinical team through a joint venture model. So we are able to bring in the best and the brightest. We are hoping to secure our third joint venture by the end of the year. And that is going to be focused in women's health and reproductive aging. And so then the other bit is, well, where are we headed? So we are opening our first clinic this year, and that will be, very early January, and that's in Belgravia, really using it to learn and refine our model. But then next year, we will have our flagship clinic in London. The priority between both of these phases is really developing this robust digital platform. So we are starting with a clinical operating system. And then we will be building and expanding upon that, and we will be adding in the patient app. So that will be July August timing next year. And then beyond those points, we sort of have two pathways, which are the partnership-led global expansion and then the tech play. So we are in conversation with some of the leading hotel groups about being able to add scaled back versions of longevity clinics in their hotels, not as comprehensive as we're talking about in standalone clinics, but being able to offer these services around the world. And then the tech play is, yeah, as we all know, as we continue to gather that data with the two digital versions that we have, we're going to be able to create this at much more mass scale. So yeah, that's all for me. Thank you so much.
Great, Sarah. Well, obviously, you've got some pretty ambitious plans there in terms of your scaling. So we've got a couple of minutes before we go on to the next presenter. So can I just ask you, you're pulling together kind of, different systems and processes, and we've just been running a survey recently of longevity clinics, which is still open at the moment. And one of the things that came back was the fact that gluing together all this complex personalized data is still quite a challenge for clinics. So you mentioned that you're kind of insourcing and outsourcing. So how are you addressing that challenge? Because it's quite a big one for clinics.
Yeah, so I mean, what we are, of course, I would say sort of the biggest challenge is you're looking at this incredible team that wants to get going and they want to be able to see as many patients as possible, but it's time at the end of the day, right? We actually had a client the other day who sent us 20 years of blood results, amongst other tests, but really it's how are you taking all of that data plus everything that he's already explained is going on, plus what those goals are and how are you mapping all of that out? So really like at the core of what we are doing. And, I don't want to get ahead of ourselves and say that tech becomes the main focus because, we've seen what's been happening in the last couple of days alone with companies. It's just that heavy tech focus. And if we don't prioritize the client at the core, we can get ourselves into a tricky situation. So for us, it's having that kind of that AI as the co-pilot, being able to utilize a lot of the technology that's out there today to then be able to utilize it to our advantage and just save time. So we're really looking at how do we cut down physician time by 30% through building this type of technology into our systems and holding that data. So that is really the priority if we're going to look at trying to scale the physician time.
Yeah. And I've got a question here from Sujay. She says, are there any specific leading therapies that you and the team are looking to use in the clinic?
Yeah, absolutely. So we are, in my opinion, sort of the standard stuff is going to be in the clinic. So we'll have the hyperbarics, we'll have the IV therapies, we'll have the red light, but we're really looking at a few areas. We're looking at EBO, we're looking at therapeutic plasma exchange. So those are going to be therapies that are offered. And of course, beyond that, we have agreements and arrangements for people looking to do the stem cell therapy elsewhere, but obviously not as a part of the clinic offering. So yeah, we're exploring and investigating. We in phase 1 will have the core aspects ready for launch, and then the phase 2 will be incorporating some of the new therapies.
That's interesting. So I guess that you're sort of leaning into this question about, okay, I'm in a hurry, I want this stuff. I'm kind of I'm in a regulated country, but I want to go into sort of more experimental things. So I guess without leading the question, you were saying is that you may be able to forward prescribe people onto some other offshore potential therapeutics.
Yeah, I mean, it's tough in the industry because there's so much kind of different viewpoints on, what's right and what isn't right. And at the end of the day, we have the medical advisory board behind us. We have our physician team. We are meeting constantly and going through the different diagnostics and therapies and what makes sense and what is according to standard, and if you are going out of that kind of realm of what you should be doing, is that justified, is that scientifically backed, is that tested? So we are very careful in our approach, but the reality is in this space, and some of these longevity physicians who are at the top of their game, it's stuff that they really do stand by and recommend. So it is going to be trusting our physicians, but really trusting our team and the medical board, which we have a very strong team behind us.
Yeah, great. Well, I mean, it all sounds fascinating. And I guess that another thing that came out of our survey was that a lot of clinics do struggle once they've established themselves, got beautiful facilities and so on, actually getting the right number of clients through the door. So you're leaning into the Founders Forum membership, which is a great starting point for you, right?
Yeah, we're very lucky to have the members that we have. And, this is something that Brent has sort of been conceptualizing for so long, that he's had these conversations. He continues to have them. People want this at the end of the day, and they just don't quite know, especially these more affluent individuals, and they don't quite know where to get it. And for us, it's becoming less of having the physical space and really replicating that space everywhere, but let's create the space now for awareness. Yes, we believe that we will need to have a few, but it doesn't need to be the high growth in that capacity. I think we will learn from it as time goes by, and then the tech comes in, and I think it's really establishing that solid foundation and being able to create that space and that awareness for now, and then we'll see sort of where it takes us in a year.
Yeah, great. Well, Sarah, thank you so much for joining us today. Great to have you on the panel as well. I know you're not able to join us later, but really interesting to see what's happening in that clinical layer. So again, yeah, thank you for joining us.
Absolutely. Thank you so much. Good to see you.
Great. Okay, awesome. So we're going to now move on to Dr. Emil Kendziorra, who is running Tomorrow Biostasis, absolutely fascinating company, definitely a level 10 when it comes to the levels of longevity. So Emil, how are you doing?
I'm doing pretty well. Thank you so much.
Great. We've got your slides. Over to you.
Awesome. Perfect. Well, thanks for inviting me. Yeah, we're switching a bit, I would say, to the moonshot side, as the slide already suggests. Of course, I'm more than happy to answer any questions that you might have in the end. Maybe to briefly introduce myself first. Yeah, so I'm a doctor by training. Spent a good amount of my time in the past in research, in cancer research, always with longevity. So longevity was always my kind of the thing that I wanted to do. Then got a bit detoured, building a few tech companies, but after selling my last two, I'm now back in longevity and building Tomorrow Bio. So Tomorrow Bio is a very unique company, as you might see in a second. So this is kind of the company that I always wanted to build, and I finally got around to do that. So who is that for, right? So far we heard about what you can do right now, and while cryopreservation is something that you can do right now, which Tomorrow Bio is offering, it is a bit more on the moonshot side, because as some of you might know, there's this differentiation between, or at least some people say there's a differentiation between health span and lifespan. Right? Everybody wants health span, no question there. Everybody wants to be healthy when they're old, right? And no one wants to be sick. Now, there's a subset of people who also say, yeah, but if I'm healthy, then I would like to also live longer, right? Of course, you can imagine that you might be 85, but if you just came back from hiking with your friends last year, right, and the average life expectancy in your country might be whatever, 86, 87, you might not like when a doctor tells you that you have a terminal condition and might die soon. And in fact, a good chunk of the population agrees with that. So around 26, depends on who you ask and how you ask, somewhere between 20 and 30% of population says, yes, given good health, I would like to live indefinitely even, which of course is arguably very long. Now, there's a good amount of drugs and treatments at least coming about that probably will expand health span. So the hope is that everybody here who is in the call and who might have a couple of years, hopefully until they're 85, then hopefully everybody is relatively healthy at 85, right? But extending lifespan, the maximum of time, maximum amount of living time, it's significantly more difficult. And currently, there's exactly 0 treatments, 0 drugs that have even expanded maximum lifespan by a day. So I would argue that we're not on track. We're not on track to live significantly longer, while we're on track to live healthy or healthier. So what to do about that? Now, as I said, we're very much taking a moonshot approach here. So we do human cryopreservation. The thing that you might know from science fiction movies, right? If you need to fly to another star, you cool down the body with a specific type of procedure, and then however long this travel to the next star might take, let it be, 40 years, you wake up without having aged a day. Now, of course, we don't primarily do this for space travel. We do this for people who are diagnosed with terminal conditions right now, right? For my background, so my background is cancer research. Let's take someone who has been diagnosed with terminal cancer, where the doctors tell them, we can take the pain away, but whatever treatment we do, unfortunately, you are going to die. You know, the only question is it 5 months, 6 months, however long, but it's relatively clear that the person is going to die soon, or it is clear. Now, as tough as this sounds, these people have two choices. They can either say, you know, when I die, I want to be cremated or buried, which, depending on your personal worldview, that is it. And of course, I personally believe that that is it. Or they can choose cryopreservation. Now, what is cryopreservation? It basically is a two-step procedure. The first step you do now, the second step you do in the future once possible. So it is a procedure where at the time of death, instead, as I said, instead of being cremated or buried, you use extremely low temperatures and cryoprotective agents. So basically solutions that you would perfuse into the body that replaces the blood and the water against a solution that you cannot freeze. So I know colloquially this topic is always calling freezing, but cryopreservation, in fact, does a lot of things to not have ice crystals form, meaning not freeze anything. It basically preserves the body in a state without ice crystals, without any form of further degradation. And as much as we understand currently, with all the physical basis of memory, identity, personality, and so on. Now, the second part comes in the future. Currently, cryopreservation is not reversible. But assuming that medical technology over the next decades and maybe 100 years or even longer advances, that then at some point, this terminal condition, this cancer, as an example, is curable, rejuvenation is possible, and it might be possible to bring the patient back to life. Is this a guarantee? Absolutely not. But then again, the alternative is cremation and burial. Now, does this actually work? Right? So in humans, as I said, it is currently still part one works. You can cryopreserve people, but you cannot currently resuscitate them. In the lab, in organs, you can very well do that. So these pictures are from one of our research partners, 21st Century Medicine. On the left side here, you see a frozen kidney. It's basically a clump of ice. It doesn't work anymore, has been damaged by the ice crystals a lot, and so on. On the right side, you see a vitrified kidney. Vitrified in this case means it has been cryopreserved by a very similar technology that we use as well. That kidney, once you warm it up from, in this case, negative 140 degrees Celsius, can be transplanted back into an animal. It perfectly works. The animal survives, and so on and so on. In principle, this is the same technology that you use for in vitro fertilization, where you cryopreserve egg cells and then, you know, make them or keep them usable for, well, many, many years. In organs, it works. In small organisms in the lab, it works. In humans, it's still an active research project. But since, again, the alternative would be cremation, it is something that humans currently can decide. So this is not just a story. This is very tangible reality. This is one of our long-term storage facilities in Switzerland. Here you see our underground long-term storage room with these large-scale so-called dewars, where cryopreserved people can be long-term stored, and not only can be, but are, at extremely low temperatures, at least negative 140 degrees, in most cases negative 196 degrees Celsius, for the long term. Just to give you a bit of a visual impression of how all of that looks, this is our research facility. The room that you just saw is here on the back underground for maximum security in a country, as I said, Switzerland, that has a good chance to be, you know, even 50, 100 years from now, to be very stable. Full operation room, CT scanning for quality assurance, and so on and so on. So everything that you need to make these cryopreservation cases happens. And of course, not everybody lives in Switzerland. So we have a lot of mobile teams as well. So these are basically retrofitted, kind of like ambulances. So we buy ambulances, then our medical engineers retrofit them to basically build mobile operating rooms that can do these cryopreservation procedures independently of where the patient might be. And then currently we have 3 of those in Europe, with our headquarters in Berlin and our facility in Zurich, and then more locations coming up. And since recently now in a soft launch also in the US, in New York, in Florida, and in California. And now over the next couple of months, we will add more and more teams both in Europe and in the US to have comprehensive coverage with these ambulances. And of course, we can fly to wherever the patient is as well if there's a last minute case. So we looked at how this looks in organs. Of course, in organs, as I said, at least in animal organs, it does work. But of course, humans, and especially the brain, is the thing that we are interested in, right? So the part that makes you and that makes me. So just to give you a short visual impression of how the quality metric, or one of the quality metrics from cryopreserved brains looks like. On the left side here, you see a CT scan in so-called pseudo color. So it's basically color-coded all areas that have gotten enough of that cryoprotective agent to not have ice crystals formed are shown in green here. And you can see the whole brain is basically green, apart from some yellow patches. These yellow patches are the ventricles and the dural sinus and so on. So areas that are not filled, there's no brain tissue in there. They're basically fluid-filled areas, meaning no important information is stored there. And last 2 slides before I'm, of course, happy to answer questions. It wouldn't be an investor conference if we wouldn't also talk about business a bit. So right now, this is an active business, right? So this is on one hand, this is active research, but we offer that service as well. Because of course, if someone gets a terminal condition right now, it doesn't really help them if we say, well, maybe in 10 years, there might be some new treatment around, or there might be some technology around that might save you if they're dying right now. Now, it's basically kind of a subscription business currently with a one-time fee at the time of cryopreservation. So most people who sign up with us, they pay somewhere around 50 euros a month to have a contract with us. Plus, in most cases, they take out life insurance. We have a large life insurance partner where this life insurance policy would then pay out at the time of death to pay for the preservation and the long-term storage. It's a 200,000 euro one-time fee in this case, or $220,000. And last but not least, there's a good amount of asset management and long-term wealth preservation attached to it that we're currently setting up. That is another big business, a business stream. So it is pretty good business now. We're close to profitable, now growing quite well, like somewhere between 5 to 10x faster than our next competitor. So good business now. And of course, once you can revive a mammal or a human, then it might be the best business ever, right? At that point. I'm not promising any timelines here, quite the opposite, in fact, but that is kind of the long-term kicker. We just crossed 100 million in contract value. So there's now 100 million worth of mostly life insurance contracts out there. I think by now it's already closer to 120 life insurance contract out there that when these people die will pay out to us for the purpose of cryopreservation. So if anybody is interested in kind of these moonshot approaches, I'm more than happy to chat. So feel free to reach out. Even if you're just interested to chat and have questions, I'm always more than happy to talk. So don't hesitate to just, send me an email or reach out on some of the other methods.
Great, Emil, thank you. Wonderful to see that actually you're bagging that revenue trajectory already, right? Which is always fascinating. Back to the science, got a question from Ashish, who's asking about the current progress or plan to enhance revival research for tissues, or obviously going to the complete organism level, even if it's just a small mammal. 2 questions, I guess. First of all is, are you actually involved in that as an organization? Yes or no? And I guess the question is what is the state of the science on that at the moment?
Yeah, so we're very actively involved. So we're not just a service provider, we're also an active R&D organization with a multitude of different angles. Our primary focus is on brain, but between organ preservation and brain preservation, it's a lot of problems are overlapping, except for that the brain has the blood-brain barrier, which gives some additional challenges. But by and large, the research is the same. The research, how far we are, so small organs you can preserve, like rat kidneys, kidneys from rabbits, and so on. Larger volumes get more difficult. The reason in cryopreservation is basically a physics problem. What I mean by that is that large volumes, just because the ratio of surface area to volume is not beneficial, it's difficult to warm them up quickly, a thing that you need to do to keep the tissue viable. So one of the reasons why I'm working in this space is because usually engineering problems are significantly easier to solve than basic research or any type of research problem. So I'm quite optimistic that down the line there will be some quite promising breakthroughs. Currently, small things work, large things are more difficult.
One last question, really, for you, Emil, before we jump into the other questions, which is, does the subscription that you've got also cover life insurance, or are there additional fees as part of that? So maybe just talk us through the model if you can, just while we prepare the other questions.
Sure. So there's basically it's two things. So on one hand, it's 50 euros or $55 as a monthly subscription once you sign up. And then at the time of death, we need a one-time fee of 200,000. Now, how you pay these 200,000, right? Definitely don't wire them to us. Like, we would need to put it in a truster account and so on. So we just need to make sure that we have it at the time of death, right? So life insurance would be in addition to these 50 euros or $55. And now life insurance costs, of course, depend on how old you are and so on, right? It's a flexible pricing scheme. You can also do a payable on death account. Some of our customers have trusts and so on. So a variety of different payment methods work. Life insurance usually is the easiest to start with. And for that, we have a large partner where it's relatively easy to sign up, no matter where you are. So we can provide life insurance contracts in every country in the world.
Okay, great. Well, in terms of our panel this afternoon, or this afternoon is in the UK, of course, we've got this mix of everybody, right? So we've got all 10 levels of longevity in the mix here. So we're going to toggle around all sorts of questions and probably confuse a lot of people. But if I could just ask you, Deep, there was one last question that came in just at the back end of your presentation, which was the sort of traction that you've got now on your customers and the kind of growth of what you're doing. Because it's interesting, you're working with insurers, you're working with hospital institutions, so you're backing into potentially large volumes of lives under management. So can you share some of the numbers with us?
I won't go specifically into numbers, Phil, but what I'll share is the interest is across industries, across regions. The way we have built the tech is it's inexpensive, because my vision is that, and I sincerely believe that biological age is a statistic that everybody on this planet should know. Like people know their weight and they know their height, they should know also their biological age. And we have priced it in a way which is really accessible. Now, along with that, I think what we have done is we have created bite-sized recommendations which are really easy to follow and actionable. So our target here is not people who have access to, let's say, specialized care and are getting very personalized advice. Even in that case, I think it is incredibly difficult and would take a lot of time for a physician or a group of physicians to put together a plan which is very specific, very personalized for every individual. It just take a lot of time. Now, if using AI, we can provide them a base which gives a level of personalization which works, and then they can fine tune it based on everything else. That is what we are seeing is very acceptable to our customers.
Okay, all right, great. Well, let's move back into the realm of the science of longevity. Kevin, you obviously gave a presentation about your very big bet on the xenotherapeutic hypothesis of aging, right? So, what have you seen that gives you the confidence to pursue what you're doing clinically, as well as obviously looking for a 100 million check?
Yes. I got into this field because I actually was an cellular immunotherapy physician. Originally was a surgeon, but then founded the first CAR T cell company before Kite and Juno, and took it public for $500 million or whatever at that time. And it was based on technologies that we had invented. We had an on switch and an off switch for T cells. It turns out that the off switch is based on inducible Cas-based technology. So there's a small molecule dimerizer that when you give it, it dimerizes Cas-based 9 and causes the cell to undergo apoptosis within minutes. And we deployed it in T cell therapies. And so if a patient got a cellular therapy and everything went well, that's fine. But once in a while, things go haywire. There's a very bad side effect called ICANS, where you get neurotoxicity and it leads to death. But if you give a single dose, if the cells carry our off switch and you give a single dose of the dimerizer, within 20 minutes, those cells are gone. And in every single case, it resolved the toxicity. So that was that company. Well, it turns out that Kirkland was using that technology, which we invented and owned, to create transgenic mice in which they expressed that off switch on a P16 promoter and then use the dimerizer to get rid of senescent cells in the body. And he made this P16 ink attack model and showed that all these diseases of aging get reversed and mice live 25% longer and all these other great things. And then there was a host of other researchers who used that same model to ablate senescent cells and look at other things like bone health, like obesity, like glucose metabolism, exercise. And in every single case, they reversed the aging phenotype. And that's how I got into the field, since I owned this technology and the proof of when I looked at all the things you could do for aging, that had the most proof of concept solid for me. I'm a scientist. I've published extensively in prostate cancer, so I know good science when I see it. So that's how I got into the field. And so we started developing a gene therapy to target that to senescent cells and eliminate them. And then while I was doing that, by accident, I came across a class of peptides that's very effective at eliminating senescent cells. I haven't seen any toxicity yet after 14 or 15 weeks of continuous therapy. And we don't really think you need more than, let's say, 8 to 10 weeks to do the job. So that's how I got into this field. And it seems very, very de-risked. The science is so strong.
Mm-hmm.
And, it's like when I treated our mice with peptides and I saw that bone health improved, bone mass went up. I wasn't surprised because somebody else used the same model I just referred to and did it before. So that's how I got into it. Now, so I feel it's de-risked. I feel that this is a type of therapy that everybody can understand. We're not targeting, molecules in the cell that are critical for other things. And I feel like if I put the right team together, this is a real opportunity to get into the clinic with a type of xenotherapeutic. I don't really see any other good. I looked at all the clinical trials being done in this field. It's mostly dasatinib and quercetin and fisetin. There's really not much. There's just a few. So anyway, that's a long-winded answer, but basically we're going in big.
Yeah. So you're going big on xenotherapeutics. And of course, that, I guess, is the gateway to the concept of perhaps systemic rejuvenation at a certain point. Greg, obviously, this is not your first rodeo, right? So you've built and successfully exited some pharmaceutical companies. So there are these concepts of, do you go disease focused and you kind of go one step at a time, and then obviously spread your portfolio once the science maybe it's protected from a big pharma absorbing it and putting stuff in the back office like Raiders of the Lost Ark, or is there an opportunity for companies to be able to take what they're doing now and expand and accelerate quickly, like we've seen in the concepts of the GLP-1s moving into cardioprotective therapies and neuroprotective?
I don't think there's a perfect model. I think it's, very much based on whether you have a platform technology. To me, the way I look at it, and for the investors on the call, this is an odds game. 90% of drugs fail, and different stages have very different metrics. The one that really resonated with me and has led to my good fortune in having two of the top 10 biggest biotech exits in the last decade with Medivation and Biohaven is to create a portfolio of 7 to 10 drugs and that are non-correlated, and then just try to be right on one. And that's based on an 8-year retrospective study that said your chance of having a successful proof of concept is 22 to 54%. 54% for antibiotics and insulin because they worked in phase 1, they're going to work in phase 2. 22% for oncology and autoimmune. Oncology because cancer is such an erratic path. So your therapy they may be on placebo, but they just go into remission. Yeah. And autoimmune because of the sugar pills. So I felt that I could probably, and my colleagues and partners, Declan and Jim, felt we could probably rewrite 1 and 3, and the nice thing is you get it right, you get a 15 to 30x return just on that proof of concept, let alone taking it to market. So just going from successful phase 2 to say phase 3. And I always tell people, just to put it in context for you, the investors, how long would you play at a table in Monaco or Vegas if 1 out of every 3 times you won 30 times your money? But you can't play once because you have a 66% chance of failure. So to circle back to your question, one, I think that, it's very important you either have the ability to create the portfolio of the investments you do. Alternatively, you find a great management team that has a portfolio, or you have a platform technology like the GLP-1 where you can continue to add. But that's still a huge binary because it could still fail on its phase 1 and then you're back to 0. So again, modify your portfolio accordingly if you have those binary events.
Now, Greg, we had a question which is a very direct question, and again, feel free if this is not appropriate, but one of your investors, who's a Portage investor, is saying, is there a plan to reshuffle some of the companies that are in your and Jim Mellon's portfolio with Serena and Portage at low cash, and of course, Ajax and so on? So there's quite a lot of complexity there. So I don't know what the nuances of all of that may be.
No, each one is an independent entity. They've got different shareholders. You're trying to maximize the opportunity for all your shareholders. So working very aggressively on all of them to maximize. And as we talked about, we've gone through a biotech winter torturous to try and raise money. But I think things are changing. And, so I'm very excited to go into the future with all 3 of those assets and no reshuffling.
Right. Okay. Got it. So another question that came in, and please, everybody, please let us have your questions because I've got a bunch of questions, but I'm sure yours are more interesting. So one came in from Jason Young, which is a bit of a sort of panel question, I guess. And I think feel free to jump in. It's saying that if aging's a burning house, how much attention or interest and resources are organizations actually putting into solving the core problem, right? So I guess what we're saying is that effectively aging is the problem. Is this resonating with people still? I mean, are we kidding ourselves? Are we in this longevity echo chamber that really actually on the outside world, people are just still focused on fixing diseases? Or are we, in the interactions that you're having with investors, are you seeing a sea change in the way that people are looking at this whole sector? Please, anybody.
I've been very pleasantly surprised that big pharma, who are the Titanic when they're trying to turn, are embracing prevention. And I think the GLP-1s, just to circle back to that, and the Ozempics, Mounjaro, have done an amazing job of showing just how big this opportunity is. Novo Nordisk, it's the second biggest company in Europe, based on one product like that. So I think that the industry has listened and heard the sounds of change. So yes, I think that there is a big difference on that. Now, to the second part, do we have any reason to believe that we can live through 125 or 150? A couple of people have mentioned that, we have not got something right now. I would disagree with them. As I said, the GLP-1s are the first anti-aging drug, not because they are changing cellular aging, but because they're limiting diseases unless you're living longer, which is the equally great outcome I think all of us would be very happy with. So how long? Don't know. And maybe we're kidding ourselves. There's lots of people who think we can live to 1,000. And that is certainly an argument. Over to you, Kevin.
Well, I'd like to add one thing there. You know, when Steve Jobs was developing the iPhone, he was famously asked, "Well, are you asking, you know, consumers whether they want an iPhone?" He goes, "Well, why would I do that? I'm just going to give them an iPhone, and then once they put it in their hand, they'll never put it down." And that's what happened. You know, if you build it, they will come. So, you know, my view is that we can talk a lot about this on webinars and all this other stuff, but you know, when we have a therapeutic that can move the needle by affecting aging in some significant way. You know, I'm betting on SENOLYTIX, but you know, there's other possible ways that that would work. But when somebody has something that is looking like a GLP-1, that is, you know, they went after diabetes and then they said, "Oh my God, it also causes weight loss." And then they did that and they said, "Oh my God, it also does all those other things." In other words, that industry happened by accident. It wasn't like Big Pharma went out to create GLP-1s. It just happened. It's just the way the iPhone happened. And hopefully just the way senolytic peptides will happen or something else. So I'm just going to do it the way I see it because I did it once before. You know, I created the first CAR T cell company. For 10 years, people told me I was wasting my time, that immunotherapy would never play any role in cancer therapy. Well, they were wrong. So, you know, I follow the science, and I think the rest of the people on the panel are doing the same. They have, you know, founders have to have belief. Everybody on this panel has a belief in what they're doing and pursuing it for the right reasons. And as was said, you know, if you can just be right on 1 out of 10 of your ideas, you know, you'll be successful. So that's how I look at it.
All right, all on red, right? That's great. So let's talk about ultra high net worths, okay? Because I guess that I was hearing from you, Greg. That's where you're getting a lot of traction from investors. I've been speaking with some ultra high net worths who are concerned that the progression of these therapeutics is still taking too long, and they are thinking about more extreme ways of enjoying their wealth for as long as they possibly can. Emil, you know, you're working with a lot of these people as well, I would imagine. So, in terms of the when, right? I mean, I guess this is the question that everybody's trying to answer really at the moment, which is we're seeing all this great science, we're seeing it progressing through clinical phases, it's getting, you know, closer one day to an approved drug. Swiss Re think it's still 30 years away. Do you guys, based on that optimism that you've got, does anybody have an opinion on how far away we are now from the likes of an aging therapeutic that's going to be a blockbuster like a GLP-1?
5 years,
Right.
5 to 7.
Yeah, I agree.
All right.
Basically, the way I see this, the way we're playing it out is we're going to go after 3 different indications and 3 different populations with a standard FDA looking trial with a primary endpoint. But then we're going to synchronize the secondary endpoints across all the trials. And if we just, so we just on the timeline of a regular trial, we'll have 3 different results. And if any of them look good, plus if the secondary endpoints all sort of start showing that it's a gerotherapeutic, not just a disease therapeutic, you know, the FDA will have to notice it. I mean, I brought on Jody Aiken, who took the TAVR to approval, and when she started, everybody was doing cardiac surgery, and now nobody does it anymore. They all use TAVR, so it can happen. It can be done. It didn't take her forever.
Okay. So, Emil, is that a flaw in your business model that all these therapeutics are going to suddenly happen in 5 years' time?
I mean, I'm not sure if the rest of the panel talks about maximum lifespan here, right? I mean, blockbuster drugs don't need to necessarily change maximum lifespan to be blockbuster drugs, right? Or anything even close to it. If anybody wants to bet that there's any drug that changes maximum lifespan in 5 years, I'm more than happy to take that bet. I wouldn't work on cryopreservation. Like, don't get me wrong. I hope you're right, right? I don't want to be right. I just much rather take whatever drug there will be around. Cryopreservation only makes sense if everything else didn't work, right? It's not a great solution. It's just the last ditch effort.
I live in Miami because I like to be warm. The idea of cryopreservation, it makes me a little shivery.
I would jump in your ice bath.
I agree. I agree.
Yeah.
I think
heat shock protein.
No, I think the trick is to think of the alternative.
Or cryo, right? I mean, why not go cryo?
I think that's unfortunately how you need to think about it. Because otherwise, I would very much agree with you.
Okay. So I mean, we're kind of touching around the concept of two aspects to longevity and health span, and I'm sure some of you will be aware of the paper that was published in Nature Aging, which was saying that human beings will never get past 125 years old, right? Just impossible. And I had a conversation with Eric Verdin, who kind of on social media was supporting the fact that we need to be more realistic about talking health span and lowering our expectations. And I guess that there's this argument in the industry, isn't there, about, okay, when is it going to happen and how amazing is it going to be when it gets here? So, of course, fixing multiple diseases of aging at the same time, those are building blocks. These concepts of systemic rejuvenation, we heard from Daniel earlier, which is, again, this kind of potential, this unbelievable potential of taking every cell in the body and returning it to its younger state. And I guess that's kind of an interesting aspect to the industry. So do you feel that the dialogue is mature enough in our industry for people to take this seriously when you're in front of investors, or people still thinking that this is a little wacko?
I think that unlimited, living to 1,000, I had a very animated discussion once upon a time with Aubrey de Grey. He said you're going to have escape velocity, and everyone's going to live to 1,000. And, I said, that's nice, but if we don't solve Alzheimer's and, the fact that I hurt my knee skiing and now I can't get up, nobody's going to want to do it. There's so many major issues that have to be resolved before we'll get there. Yeah. To Emil's point, whether I personally think 121, 125. So, that's a meaningful change if you're healthy until then, which would be fantastic. Beyond that, I don't know. I know, Kurzweil talks about us having a wet body or a dry body. So there's all sorts of variables in this equation. But I think that we'll add in the 5 years, 7 years was not, immortality. It was 10 more healthy years, which, by the way, doing what Deepankar is doing, just helping people with their lifestyle changes, would probably add 4 or 5 years.
Yeah. And I guess that's, you helped me out there, Greg, because I was going to pull deep into the next phase of this conversation, which is I've heard that insurance companies, albeit that if they're pension companies, they don't want this, right? If they're life insurance companies, they want it. But I have heard that institutions are starting to consider hedging the concept of longevity, that obviously they've got a portfolio risk as it is now, so they can rebalance that portfolio risk by investing in some of these companies. So I guess the question I had for you, Deep, was, you're talking with insurance companies. We are aware of this specter, whether it's a good thing or not, that biological chronological age is coming into the insurance industry. So can you tell us what you're experiencing when you're speaking to these firms?
Yeah, absolutely, Phil. So I'll just take comment on one point which was discussed before. See, our approach is a pick and shovel approach to longevity, right? And what we are trying to say here is, like, we want to partner with everyone, right? We have built technology that is essentially, so when someone says, he's doing that, I don't see anybody in the industry who is like my competition. I think I can partner with everyone, right? If you are doing clinical trials, then potentially you would like to use our biological age clocks as an important statistic. And if Emil is looking for people to join, then he would definitely like to motivate them by telling them that, their biological age is more, and then they should be taking care. Insurance companies have regulations. So even though they want to do quite a few things, they can't. Even though they would want to come up with personalized products, they can't issue policies to select people in the population. Then all the insurance companies would want to just have the healthy population with them, and nobody would insure people who have disease conditions. So they have inherently a lot of restrictions in terms of what they can do. I've spoken to insurance companies who have told us that we have built in-house models which can predict mortality and do a lot of other things because we have so much data, but we really can't action on that. Mm-hmm. What we are trying to tell them is you can use longevity to really engage with your customers, right? Once you have insured them and you want to then address your bottom line, it is in your interest to keep them healthy. And if you do that, then it works for you, right? And then, please go ahead.
I was just going to answer what Phil had said before. Phil, were you referring to Jay Olshansky's paper? Because I've been talking to him a little bit about that. So
yes, I was.
Basically what he said was that all the increase in average lifespan over the past 100, 200 years was because we were just improving simple things like, washing your hands, food safety, all that stuff, and that anything now in the future would require some kind of a major advance in something fundamental. And actually, I was showing him some of our data, and he thought that, xenotherapeutics would be a potential candidate that could change what he said, which is he said now based on current, go ahead.
To interrupt you, Kevin, I think it's for the benefit of our audience. But basically, what it's like a 30-year study of a retrospective study of population, age, interventions, and it was in the rearview mirror, right? So what you're saying is that these types of papers are great. They help debate, but likewise, they're not taking account of what's going forward. So we're all optimists on this call, right? A lot of our audience are optimists. So really what you're saying is that we're waiting for these breakthroughs, right? And xenotherapeutics could be one of those. Cellular reprogramming could be another. And I mean, I guess I don't really know that there's any others that I could say that have that kind of level of hope behind them that I'm seeing in the industry from that systemic perspective.
Right. Until you change the world, nobody sees it coming. Most of the experts never really saw the next big thing until it passed them by, because, who would? It's human nature, to be, not to be able to be able to do that. So I think, I agree. I do think it's 5, maybe 7 years away till we'll have a major advance. And, 35 years is really a pessimistic view. If that's the case, that would be sad.
Yeah,
well, if they're in the reinsurance business, they're in for a shock.
Yeah, so I mean, I guess the thing is that institutional investors, which there may be a few on today's call, I guess there's a whole mixture of individuals as well as institutions. Greg, you were doing the rounds, right? I can remember when you guys were speaking with Bank of America and stuff back when I first started meeting with you guys. I mean, do you feel that they're getting it yet, or are they still outliers?
No, I think the banks are way ahead of the investors.
Really?
Bank of America said that it's going to be $500 billion industry in like 3 years. McKinsey said it's going to be $1 trillion by the end of the decade, 2030. Citibank, Yigal said that this is one of the top 10 biggest, transformative technologies of this decade. So they get it. And they're very watchful. And by the way, I went in, we met, Jim Mellon introduced us to a pension fund, and they were as hip as we were. I mean, like their science they had it all. They knew what was going on all the way through longevity, this pension company. So they're on to this. They're watching it very, very closely. And they talked about, the fact that investing in us might be an arbitrage on their pension. So it's happening. And so now we have to catch up. We need a couple of successes, to get everybody incredibly excited about the sector. And I still think, Emil, there's going to be a business for you, because I'm not convinced anytime soon we're going through 200. So people still may want to do the cryotherapy. And then also, obviously, they need to work on their lifestyles as well, because a lot of us are shooting ourselves in the foot with what we do.
Yep, as do we all. And I guess from our audience's perspective, I wanted to thank you all really for your presentations, which were great, as likewise this panel session. Of course, it always feels a bit truncated when these conversations really start juicing up. They've actually got to wrap things up. So I'm so sorry that we can't continue, but thank you so much to the panel. It's been great. And thank you, of course, to our audience for joining us today. And of course, thanks very much to the Master Investor team who's done a great job of putting all of this together and bringing it into a very, very seamless webinar. So Longevity Week continues in London. There are lots of events still happening. So from myself and from everybody, live long, live healthy. Take it easy. Thanks for joining us.